Now, moving on. Let's expand this concept of broadcast domains to something we call virtual local area networks, or VLANs. To hit home the concept of what a VLAN is, I'm going to go through a little example to hit home why we need VLANs. Let's assume, or pretend, and we're going to do a lot of pretending in this class, we have a switch 1, and we have 4 PCs attached to it. And let's say these PCs, PC1, PC2, PC3, and PC4. Let's say this switch 1 belongs to the accounting department for some company. So now this switch belongs to some accounting department for some company, and I know I haven't covered IP addressing right now, but you don't need to know IP addressing to understand this concept, so just go along with me. Let's say this accounting department has an IP address or network address of 10.10.10.0. And then PC1 is assigned the address 10.10.10.1, PC2 is 10.10.10.2, PC3 is 10.10.10.3, and PC4 is 10.10.10.4. Now suppose the same company also has a management department. So this is switch 2, and there are 2 people in management, and we'll call them PC5 and PC6. Now the management department would have a different IP addressing scheme, not 10.10.10.0. It would be, let's say, 20.20.20.0. This is just for example's sake. Why can't we put PC5 and PC6 on switch 1? Well, we can't, because the management department has a different IP addressing scheme, and if PC1 sends out a broadcast at some point, everybody would receive it if they were all attached to switch 1. So if I put PC5 and PC6 on switch 1, PC5 and PC6 would receive that broadcast. However, they're supposed to be separate, a separate department from the accounting department. So what do? Not to mention the fact, switches don't have just 4 ports. You can buy switches with 24 ports. I think the least amount of ports you can buy are 12, but most places have switches that have 48 ports and above. So over here, let's say I had 24 ports, I'm wasting 20 ports. And I pay money per port when I purchase this equipment. So not only is it insecure to put PC5 and PC6 on the same switch, it is also a waste of money. I'm wasting 22 ports on switch 2 because nobody else can be on the same switch where the management department is located. There's no separation. So the separation comes by having a physical separation, just buying different devices. But then you run into the problem where you're wasting ports. What if I do put PC5, which is 20.20.20.5, and PC6, which is 20.20.20.6, on the same switch? And let's pretend PC1 is connected to port 1, PC3 is connected to port 3, PC2 is connected to port 2, PC4 to port 4, 5 to port 5, and 6 to port 6. Whoops. Port 6. Now let's say inside of the switch, I log into the switch and I do some configurations where I tell the switch that P1, port 1, port 2, port 3, and port 4 belong to LAN number 10. And port 5 and port 6 belong to LAN 20. Now what I've done is I've actually created 2 switches, 2 virtual switches inside of the same physical device. So instead of there being a physical separation of the accounting and the management department, there is a logical separation inside of the switch. So I have created two virtual switches inside of one switch. And a switch is basically a LAN. It's a local area network. So I have created two virtual LANs inside of the same physical device. So instead of calling this LAN 10, I can call it VLAN 10 or virtual LAN 10. And I can call the management department VLAN 20. So, coming back to VLANs. VLANs are nothing more than virtual switches inside of the main switch. So, VLANs are nothing more than different virtual switches that you create inside the main physical device. Now, the benefits of VLANs. One, you're saving yourself money by using up all the ports on a switch. Two, VLANs can traverse different switches. So now the distance constraints have been taken away. A VLAN can extend from the floor I'm on to the basement of this building, and as long as the users or the PCs connected to those switches belong to the same VLAN, they will talk to each other like they're sitting next to each other. So the distance constraint is gone. So remember, VLANs can traverse multiple physical switches. VLAN 1 on a switch and VLAN 1002 through 1005. That's 1002, 1003, 1004, and 1005. And VLAN 1 are default VLANs, which means they already exist on the switch, and they cannot be deleted. Okay, so VLAN 1 and 1002 through 1005 are default VLANs, and they cannot be deleted. Now, by default, all ports on a switch belong to VLAN 1. Once again, by default, and I'll be showing you that in a few minutes, by default, all ports on a switch belong to VLAN 1. VLAN ranges, total VLAN ranges, depending on the platform, depending on the switch and the operating system that you're using, the total number of VLANs you can have on a switch vary between 1 and 4094. So VLAN 1 through 4094 are the total amount of VLANs that you can possibly create on the switch, depending on the platform. Now, just because you can choose to create VLAN 3000 doesn't mean you need 3000 VLANs on that one device. You could only have VLAN 3000 and VLAN 50, and you would be fine. Now, this little bit of information is not exactly CCNA specific, it is a little bit beyond, but take note that VLAN 1 through 1005 are called normal range VLANs. VLANs 1006 through 4094 are considered extended range VLANs. Now, extended range VLANs will come into play a little bit later. I'll mention it when I'm covering another topic called VLAN trunking protocol. So we will put that little tidbit on the back burner till then. So now we go to the next stage, VLAN configuration. So the next topic we're going to cover is VLAN configuration. For your benefit, I'm going to write the commands on the board, and then I will show you on Packet Tracer. So there are two ways to create VLANs, the old way and the new way. The old way is actually not part of CCNA. I'll go ahead and cover it in my classes anyways, because most of the people listening to this lecture or most of the people that are in my classes are in production. And not everybody has the most upgraded iOS at work, and not everybody can afford to buy new switches all the time. So you might run into a switch at some point that just doesn't do it the new way. So you need to know the old way just for work purposes. And it is not hard. It is very simple. So on a switch, in the old way, you simply say VLAN space data base. And the Cisco command line is not cap sensitive. So it could be capital, or it cannot be capital, or it can be lowercase, and it'll work just fine. except for passwords. Passwords are case sensitive. So when you hit the return key or when you hit enter, the switch changes modes to switch, it'll say VLAN, which is your VLAN database mode. Over here, VLAN, let's say 50, and hit enter. And if you want to give it a name, you can say name, let's say test. And when you hit enter, it will create VLAN 50. At that point, you can say exit. And you will return back out of the database mode. And then you can check your configurations by doing the command show VLAN or show VLAN brief, which is the preferred command, or at least I think it's the preferred command. And in about 5 minutes when I do these commands, I'll point out the difference between the command show VLAN and show VLAN brief. Now, this is the old way of doing it. Okay, this is the old way method of doing VLANs. Now, the new way. For the new way, you need to be what is called the configuration mode for the switch. And once again, we're nearing the point where I will have to stop theory after VLANs are done and then move over to show you how to operate or how to navigate the Cisco operating system. But we'll get to that in a little bit. So for the new method, you need to be in config mode. And you will understand what config mode is by the end of the day today. From config mode, you would say VLAN, let's create VLAN 100. And when you hit the return key, you will see that the mode for the switch changes over to config VLAN. And now you're configuring the VLAN database on a switch. Over here, I can give it a name, name CCNA, and that should create my VLAN 100. Sometimes you can run into an issue. Sometimes people do a show command from this mode and try to see if the VLAN has been created. And there is a way to do a show command from this mode. You can simply, instead of saying show VLAN brief, say do show VLAN brief. However, the caveat here is, and I've noticed this personally, and I have a home lab, I've noticed this on my home lab, some of my switches will show me VLAN 100 at this point. Fine and dandy. Sometimes the switch does not digest this command till you actually exit out of this mode. So if at this point you check to see if you have VLAN 100, sometimes it leaves people confused because they don't see VLAN 100 in the database. And they are thinking that, hey, I just did the command. Where's my VLAN 100? What they need to do is exit out of this mode. Go back to your config mode and check again. Or you could go back a lower mode and check again. But now if you check with the command do show VLAN brief, you will see that VLAN 100 is there and it's present. Okay, now at this point I'm going to pull up Packet Tracer and show you how this works.